Homework 2, problem 8. Find the electric field above the center of a disk of charge, as shown in the figure. To do this, I'm going to use the result from the previous problem. The result was that the electric field due to a hoop, a distance z up, was lambda r z divided by 2 epsilon naught r squared plus z squared to the 3/2 power. Now this was for a hoop, so I have to figure out how to make my disk out of a bunch of hoops. To do that, I can think of breaking the disk into a bunch of little lines. The disk will have a radius r prime, and it will have a width dr prime. The length per unit charge is going to be equal to the surface charge density times this dr prime. So my total electric field now for my disk, which let's change marker colors, let's change to blue. My total electric field for the disk now is going to be the integral over r prime from 0 to little r is sigma dr prime r prime z over 2 epsilon naught r prime squared plus z squared to the 3/2 power. Now we've already pretty much done the problem, which all we really needed to do was set up the integral, because this again is a physics class, not a math class. And so we know we can use whatever method we want. I here use Mathematica to do it, so that gives me that integral. And now I can simply write down that the electric field due to this thing is going to be equal to, let's see, sigma over 2 epsilon 1 minus z over the square root of r squared plus z squared z hat.